TD equals the absolute value of S of 1, was it F? It was F, yes. F of 1 minus F of 0 plus F of 3 minus F of 1, all in absolute value, plus F of 5 minus F of 3, and plus F of 6 minus F of 5. Now we have to put in all these values in the graphing calculator and determine the value. So I'm going to share my screen so we can put it in the graphing calculator together and plug it in. Okay, so okay, somebody came in. Well, how do I find that person now? I have no idea. Okay, here it is. Okay, so in y equals, and remember, you have to have the mode in radian mode. So be careful with that. So I'm going to put in the function, and the function was sine pi t. Sine pi t divided by 2 and close the parenthesis. And then all I have to go and quickly plug in 0, 1, 1, 3, 5, and 6. Okay, so obviously 6, this means 0. That's the error of the calculator. -1 times 10 to -13 is 0. So then we have 1 minus 0, which is 1. Minus 1, so 3 minus 1 plus 1. So this is positive 2. And then 5 minus 3, yes. So 1 minus, so that's another 2. And 0 minus 1 with the absolute value is 1. So we got 6. Now we need a measurement unit. What was the measurement unit? What was it? What was the measurement unit? Seconds and S in feet. Okay, perfect. So that's feet. Okay, anything else? Is there another question?
The last one I have on this is just the second derivative.
You mean the acceleration, and they want us to, when it speeds up and slowing down, right?
Yeah, but just the acceleration.
Okay, so remember the velocity is this. So I have to copy pi over 2 first. So the acceleration, we have pi over 2. And we have to differentiate cosine. When we differentiate cosine, we have negative sine pi t over 2 times the inner function prime, which is pi over 2. So the final simplified form will be pi squared over 4 sine pi t over 2. Do they want us to determine speeding up, slowing down, anything like that, or not?
Yeah, but I just wanted to see what I was doing wrong with the second derivatives. So that's enough. Thank you.
Okay. Good. So now you have to set this equal to 0 and determine all the necessary points between 0 and 6. And don't stop. Meaning, if you find t equals 1, t equals 3, continue till you exceed 6. Okay?
Thank you.
We cannot stop. So, of course, this is irrelevant. So you have sine pi t over 2 equals 0. And remember, for sine is 0 here and here. So we have 0 plus 0. First of all, 0. Then 0 plus 2 pi. Then 0 plus 4 pi. And then 0 plus 6 pi. That would be beyond. Now, then you have pi as the first solution here. And then pi plus 2 pi. And then pi plus 4 pi. And so on and so forth. Till t is anywhere between 0 and 6. Okay, perfect. Is there anything else? Very good question. Anything else? Other questions? Anyone?
Yes.
I'm ready. I think Chris was next.
Oh, okay.
Sorry, Chris, what was your question? But Cameron, you had only one question or two?
I want to look at the next question again after
Okay.
reviewing that one.
Okay, perfect. So, Chris, you're next.
Okay.
Do you have it?
Yeah, there are a few things I'm kind of looking at.
Okay.
But I'll go for let me see. Let me find. So let me read you what this is from the derivative assessment. So
Yes.
obviously we won't do this one.
Yeah,
but
that's let me copy it and then I'll make one up, or you make one up.
Derive implicitly y
Differentiate
equals,
implicitly. Perfect.
Differentiate implicitly. Y equals x to the power of 5x and then squared.
Like this.
All right. So it's not within parentheses, but I guess it probably could be.
Is it like this?
That's
no. This is totally. These are totally different.
Okay.
This means x to 10x, and this one means x to 5x squared. Yes. So is it this or this?
It's the second.
The second one. Okay. So we had a situation last time that was similar to this. I don't remember who asked. I don't want to waste the time and go back and look. So, you know that this is a two-step procedure, correct?
Yes. You take the natural log of both sides.
Yes.
Yeah, and then the algebra.
Yes.
Is tough for me.
So, let's say y equals. Can I put in anything else, or they have to be polynomials?
You can put in whatever extra steps or whatever.
So the functions can be anything.
Can it be something like this though?
I'm sorry?
Can it be something similar to this?
So you want polynomials, you mean?
Yeah.
Okay. So I'm gonna write 4x raised to or even 4x squared raised to 3x to the fourth. They're all exactly the same. We apply natural log. We bring the power in front. And now we differentiate implicitly. So when I differentiate this, I have 1 over y dy over dx. I differentiate as a product because I have to. This prime will be 12x to the third times natural log 4x squared. Maybe I should put in parentheses, it's easier to see. Plus 3x to the fourth times 1 over 4x squared times the inner function prime, which is 8x. I will try to clean it up a little bit. So 1 over y dy over dx equals 12x cubed, natural log of 4x squared. And then plus, I will simplify the 4 with the 8. I will simplify an x with an x. But I also will simplify x with an x from here. So I have plus 3x to the third. All I have to do now is rewrite, multiplying both sides by y, which was 4x squared raised to 3x to the fourth, x to the fourth, and I copy this. Natural log of 4x squared plus 3x cubed. Is this what you meant?
Yes. Did you, wasn't there still a 2 as well? Shouldn't it be 2, or shouldn't it be 3x to the third times 2?
Yes, I forgot the 2. I put it up there, so yes, you're right. I'm correcting it in red. Yes, I forgot about this 2. Yes, 2 times 3.
And then, yeah, and then you multiply by the original y.
It's right here.
Yes. Okay.
Good.
I understand.
Perfect.
Thank you. Okay.
If you go back, this is a very simple situation, but please go back to all the examples we did in class that were slightly more sophisticated than this one. Good. Next question. Who's next, please?
Can anyone go or?
Yes, anyone. Yes.
Okay, yeah, I had a question.
Yes, please.
I don't remember what section this was in WebAssign.
Okay.
But The first is y is equal to square root 6 plus 4e to the 9 times x. Like x is in the, x is down, not an exponent. Like the x is not an exponent. Like it's not to the power of anything. It's just down.
So let's write it again. So y equals the square root of
6 plus 4e to the 9th power, then times x. Yeah.
Okay, perfect. So what are we trying to do?
The y prime.
Okay, so for y prime, we have 1 over 2, the square root of 6 plus 4 e to the 9th x, multiplied by 4 e to the 9th. I'll simplify by 2 and have e to the 9th over the square root of 6 plus, of course, 2. 4 e to the 9th x. Is that okay?
One question: why are you multiplying by the 4e to the 9?
Because we have the formula, the rule, the square root of a function prime is 1 over 2 the square root of the function times the function prime.
Okay, yeah.
Good. Other questions? Anyone? Anyone else? Other questions?
I have another one.
Yes, I'm ready.
I think this is from 3.11,
Good.
and then f of t is equal to natural log sine h.
Hyperbolic sign.
Yeah,
Yes.
hyperbolic sine.
Good.
Yeah.
Good.
And then 4t.
Good. That's it?
Yeah.
Perfect. So we have f prime of t, which is 1 over this hyperbolic sine 4t. This is the first function. Now I differentiate the second function, cosine 4t. Now I differentiate the third function, times 4. Cosine over sine, even if it's hyperbolic, it's still tangent, but you know it's not the tangent function, so, or cotangent. So cotangent hyperbolic t. It's like cosine over sine. Cosine over sine is cotangent, and 4 goes in front.
Okay, thank you.
My pleasure. Anything else? Anyone else? Other questions? Anything?
I have another one. If
I'm
nobody
ready.
else-
I'm ready.
Sorry, I was looking at 3.11. I have to go back now.
That's okay.
Some of those word problems are really bending my brain as well. But this is from
Yes?
It's from 3.5.
Yes.
And it's number 12,
Yes.
which states find equations of both the tangent lines to the ellipse x squared plus 9y squared equals 81 that passes through the point 27, 3.
Perfect. Okay. So, how do I know that this is an ellipse, other than they told me that it's an ellipse? Well, I really have to divide both sides by 81. When I divide both sides by 81, I get x squared over 81 plus 9 over 81, which is 1 over 9, y squared over 9 equals 1. Why did I choose 81? Because this has to be 1 in order to identify the characteristics of the ellipse. So that's the reason why I divided x squared by 81, 9y squared by 81, and then 81 divided by 81. Okay. Now, this tells me that because what's under x squared is bigger than what is under y squared, it means that it's this kind of ellipse, not this kind of ellipse. So on the horizontal axis, on the x-axis, how far this way? 9 and 9. How far this way? 3 and 3. The square root and the square root. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, negative 9. 3 and 3. 1, 2, 3. 1, 2, 3. Negative 3 and 3. So the ellipse passes through these points. I'm going to try to graph a good ellipse. Let's see if I can. So, oh, good. So this is our ellipse. Now, 27 comma 3. So this is 9, another 9, and another 9, comma 3. So this will be a point somewhere here. So this is at 9. So I'm going to say this is at 27. And of course, it has to be here at 3. Right? So we are told that we are asked to find the equations of two lines that pass through this point, 27, 3, and both equations are tangent, both lines are tangents to the ellipse. I already found one. What is this line? It passes through the point 27, 3, and it's also tangent. But this is just a specific situation. So we already know that one answer is this. It's the equation of the tangent line to the ellipse passing through this point. No questions there. I'm looking at the time here. I have 18, 19.